Am I audible?
Yes, sir. Good evening, sir.
Okay. In last class, I defined you two different types of heat. One which causes to change in temperature of particular substance, and the other which causes to change state of that particular substance. Now, on the basis of that concept, let me define you how to approach a problem. So for that, let me define you graphical representation. Let's say vertical line is temperature. Just 1 minute. And horizontal corresponding change or corresponding applied heat. Suppose we have ice at some initial temperature minus 10 degrees Celsius. So on giving heat to this particular substance, there will be change in temperature from minus 10 degrees Celsius to 0 degrees Celsius. This particular heat, which causes to change in temperature of substance, is called specific heat. So on going from this point to this point, it will be termed as specific heat in changing temperature of ice from minus 10 degrees Celsius to 0 degrees Celsius. Now, from this 0 degrees Celsius, we have ice. On further giving heat, it will tend to convert into water at this point. During this, there will be no change in temperature since the amount of heat supplied to this ice get utilized in breaking of bond. So there will be no change in temperature. So it will be keep as it is. So this particular amount of heat is called latent heat of fusion. Now, on further heating, it will tend to increase its temperature from 0 degrees Celsius to maximum 100 degrees Celsius. So this is called specific heat since temperature of water is changing from 0 degrees Celsius to 100 degrees Celsius. Now on further heating, state of water will now start changing to vapor at same temperature 100 degrees Celsius. So at this point, amount of heat supplied to the system is utilized in breaking of bond, so there will be no rise or fall in temperature of liquid. On converting completely into vapor, this change from water into vapor is called latent heat of fusion. And on further heating, it may rise in temperature like this. So for any conversion, you just use this particular graph. Atif, is it clear?
Yes, sir.
Okay. So first question related to this particular graph may be asked to define slope for this inclined line. Let's say this particular inclination is theta1, this particular inclination is theta2, and this particular inclination is theta3. So you'll be asked how theta1, theta2, and theta3 is related with one another.
Sir, can you scroll up?
We have just started.
Okay.
Okay. So for this graph, we have vertical line temperature and horizontal line heat. So this theta may be defined on the basis of vertical line temperature and horizontal line heat, or we can say slope of temperature versus heat. Is it clear? So
Yes.
this particular line is defining you nothing but change in temperature, which will be termed as specific heat. So we may write dq equals to mass of substance, specific heat constant related to that part times change in temperature. So for this graph, we have temperature in perpendicular side and heat on base side. So move this dq towards right and rest of the term towards left. So you'll get 1 divided by m into s equals to dt by dq. Now in this ratio, we have dt in numerator, which will behave as perpendicular, and dq in denominator, which will behave as base. So this particular ratio will be termed as slope of this particular graph. Mohammed, is it clear? Atif?
So can you explain once more?
Just 1 minute. Yusuf, just wait. I'm replying your message. Okay. In this, we have these straight line,
Okay, sir.
this line, and this line for a specific heat. So this inclination may be defined on the basis of a specific heat. So I've just written formula for a specific heat. Heat equals to ms delta T. So this is the formula how to calculate a specific heat or change in temperature, which I defined in last class. Okay, Atif?
Yes, sir.
So we have to convert this particular relation to find slope of this particular graph. So in this graph, we have perpendicular as temperature and base as heat. So I've moved this dq towards right and m into s towards left to get dt divided by dq. So dt will be termed as perpendicular and dq as base. So perpendicular divided by base will define you nothing but slope of this particular graph. Okay.
Okay, sir.
Now this particular slope is related with specific heat constant S, or we can say slope of this graph is inversely proportional to a specific heat of that particular substance. And in last class, I defined you a specific heat constant for ice, water, and vapor as well. So from this, we can say the more the value of a specific heat constant for that particular substance, it will have a smaller slope. So let me remind you about the last class. just see the value of specific heat constant for water. For water, it will be 1 calorie per gram per Kelvin. And for ice and vapor, it will be 0.5 calorie per gram per Kelvin. So we can say inclination of ice and vapor, since both having same value of specific heat constant, so their inclination or slope will be same. And for water, it having more value of specific heat constant, so its inclination will be smaller as compared to ice and vapor as well. Atif, is it clear?
Yes, sir.
So from this, we may conclude since specific capacity of ice equals to specific capacity of vapor, and which is smaller as compared to a specific capacity of water. So in terms of inclination, since slope is inversely proportional to specific heat, the more the value of a specific heat, it will have smaller slope. So we can conclude θ1 and θ3 will be equal to each other and will be greater as compared to θ2. So this will be a relation between θ1, θ2, and θ3 related to this graph. Is it clear?
Yes, sir.
Okay, just write it down this part. You all have written?
Yes, sir.
Nida, any doubt?
No, sir.
Atif, done?
Yes.
Yusuf?
Yes, sir.
Okay. So let me define you how to calculate or solve problem related to this part. If done 10 gram ice at 0 degrees Celsius is mixed with 20 gram water at 100 degrees Celsius, find their resulting temperature. So for these type of problem, how will you define or solve? So first, try to draw graph related to these two substances. Let's say this is Q and this is T. So we have 10 gram ice at 0 degrees Celsius. So it will be at this point, ice at 0 degrees Celsius and water at 100 degrees Celsius. So it will be at this point. So what will happen? Ice will require some amount of heat to change in state from ice to water. So it will tend to go from this point to this point to convert into water. So this amount of heat required by this ice to change its state, let's say Q1. So it will be termed as latent heat of fusion. Is it clear?
Yes.
And then due to further amount of heat, if present in this particular system, then it will rise up to this point for equilibrium. Let's say temperature at this point is T. This process or this heat supplied to this ice to change its state or to raise its temperature must be fulfilled by water by decreasing its temperature from this point to this point. So we can say the amount of heat lost by water to change its temperature from 100 degrees Celsius to T degrees Celsius must be absorbed by ice to go from 0 degrees Celsius to T degrees Celsius. Is it clear?
Yes, sir.
So let's say this is Q1 and this is Q2. So you can say heat absorbed by ice must equals to heat lost by water. Now for ice, we have Q1 plus Q2, and for water, we have capital Q1. This small q1 is heat required to change its state. So we can write it as mass of ice, latent of fusion constant. Q2 is heat required to change its temperature from 0 degree water to some T degrees Celsius of water. So this will be termed as specific heat. So it will be T minus 0. Capital Q1 is amount of heat lost by water to go from 100 degrees Celsius to T degrees Celsius. So this will be again termed as specific heat. So mass of water, specific heat capacity of water, and change in its temperature, that is 100 minus T. Now put the value of each part and simplify it to find T. Specific heat capacity of water is 1 calorie per gram per Kelvin, and latent heat of fusion of ice is 80 calorie per gram. Just put the value of these two parts in this equation and try to find T. Reba, any doubt?
No, sir.
Okay.
So should we convert the grams to kilograms?
No, you have to calculate as CGS unit in terms of gram. Okay.
Okay.
So you'll get your energy in terms of calorie.
So are you taking the heat capacity of water for Q2?
Since water is initially at 100 degrees Celsius. So when you go from this point to this point, this heat will be termed as a specific heat. So we can say specific heat of water will be 1 calorie per gram per Kelvin. That's why capital Q1 is a specific heat
No,
of
sir.
this.
Why are you taking for Q2?
Okay, Q2.
Yeah, why are you
Since
taking
on
specific heat of
converting,
water?
since initially ice was at this point, so its state is ice. So on completely melting to this point, it will get converted into water. So now its state is water. And then its temperature is raising up to some T. So what will be state of this ice at this instant? So you'll say water.
Okay, sir.
Riba, you got any answer? Mohammad Irfan? Okay, we have mass of ice as 10 gram. Latent heat of fusion of ice is 80 plus mass of ice, which is 10 gram. Specific capacity of water is 1 and change in temperature is T minus 0, so keep it as T. Next, mass of water is 20, specific heat capacity of water is 1 multiplied by 100 minus 20 into 1 multiplied by T. Now move variable to one side and constant to one side. So it will be 10T plus 20T equals to 20 into 100. So it will be 2000 minus 80 into 10, 800. So 10 plus 20, 30T, 2000 minus 800, it will be 1200. So T equals to 1200 divided by 30. 0 and 0 cancel out. 3 fours are 40 degrees Celsius. Atif, is it clear?
Yes.
Yusuf, any doubt?
No, sir.
Nida, any doubt?
No, sir.
Okay. Mohammed Irfan, is it clear after this part what we have written? Okay. Mass of ice is given in the question as 10 gram. We have latent heat of fusion of ice as 80 calorie per gram, according to this. Mass of ice, 10 gram, but now it had converted into water. So we have to calculate for this part. So it will behave as water having specific heat as 1. T minus 0 will be T. Mass of water, which is at this point, having mass 20 gram. So it will be 20. The specific heat of water is 1. Change in temperature 100 minus T. So this particular term first multiplied with this part, and similarly, this particular term multiplied with this part with negative sign. Now move variable part to one side and constant part to the other side. So we have 10t towards left. This term on multiplying will become minus 20. Move it to left side, so it will become plus 20. 80 to 10, 800, and 20 into 100, 2000. So I'll move this term to the right side. 2000 minus 800, 1200, 10 plus 30. T will be equals to 1200 divided by 30, that will be 40 degrees Celsius. Mohammed Irfan, is it clear now? Okay. You all have written?
Yes, sir.
Nida, done?
Yes.
Okay. Let me give you another problem. If $60 ice at 0 degrees Celsius is mixed with 60 gram steam at 100 degrees Celsius. Find temperature at equilibrium. Let me define you how to approach this part. First, we have ice at 0 degrees Celsius and steam at 100 degrees Celsius. So ice will require some amount of heat to convert its state. We have ice at this point. So it will require some amount of heat to go from this point to this point. So it will be Q1 to convert into water. Similarly, this amount of heat must be provided by steam to go from this point to this point in terms of Q1. So first try to calculate small q1 and capital Q1. Try to solve. Q1 will be latent heat of fusion, mass of ice times latent heat of fusion, and capital Q1 will be latent heat of vaporization, mass of vapor times latent heat of vaporization. Just put the value of these two parts and try to find small q1 and capital Q1. Atif, you got any answer?
Calculating, sir.
Okay. Yusuf, you got any answer?
Yes, sir. Calculating.
Just see, we have mass of ice as 60 gram and latent heat of fusion of ice is 80. So on multiplying 8 into 6, 4800 calorie. So this much amount of energy would required by ice to convert from ice into water. Now, for this capital Q1, we have mass 60 gram, latent heat of vaporization is 540. So on multiplying 6 into 4, 24, 6 into 5, 30 plus 2 calorie. So which is in larger amount, capital Q1 or small Q1?
The capital Q.
It means we have large amount of heat energy in this particular system. So this ice on converting into water may raise its temperature to reach at this point. So it would require, let's say Q2, to change its temperature from 0 degrees Celsius to 100 degrees Celsius. So let me calculate Q2 equals to, now it has converted into water. So specific heat capacity of water, change in temperature, 100 minus 0. Mass of water is 60 specific capacity of water is 1, change in temperature is 100. So on multiplying, you'll get 6,000 calorie. Now add these two. We have 4,800 calorie above and 6,000 below. On adding these two parts, you will get 6,000 plus 4,000, 10,000, 800 calorie in total required by ice to go from 0 degrees Celsius to 100 degrees Celsius. Now just compare, is we have more amount of heat energy left out in this particular system still? We have 32,400 calorie heat energy in this particular system. But for this conversion of ice into water, we just required 10,800 calorie. So you can say still we have some large amount of heat energy left out in this particular system. Is it clear?
Yes, sir.
Atif, is it clear?
Yes, sir.
So we can calculate net amount of heat left out in this particular system as 32,400 minus sum of these two terms, 10,800. So if you subtract these two parts, 14 minus 8, 6, 31 minus 10, 21 calorie. So this much amount of heat energy still we have in this particular system. And this amount of heat will tend to convert some of water into steam. Is it clear?
Yes, sir.
So we may find using formula Q equals to mass times latent heat of vaporization. We have Q, we have latent heat of vaporization, just trying to find mass of liquid that will convert now into steam. So Q is 21600. Latent heat of vaporization is 540. So this 0 and this 0 will cancel out. Just divide this part and you'll get your answer. 2160 divided by 54. You'll get 40 gram. First write it down, then I'm defining what is happening here.
So can you scroll up? Okay, sir.
You all have written?
Yes, sir.
Yusuf, Dan,
Yes, sir. Done.
Atif?
That's all.
Okay, let me define you what is happening in this part. Initially, we have ice, so it requires some amount of energy, Q1, to convert into water. Further, it will require Q2 amount of energy to convert into water at 100 degrees Celsius. So at this point, temperature is 0 degrees Celsius, 0 degrees Celsius, and 100 degrees Celsius. At the same instant, steam initially at this point will lose some amount of energy to get condensed from this part to this part to convert into water at temperature 100 degrees Celsius, 100 degrees Celsius. So amount of energy evolved by this steam was Q1. So at this instant, we have 60 gram of steam and 16 gram of ice, which simultaneously have converted into water itself. But in this part, still we have some amount of heat energy left out after this conversion, which is 21,600 calorie. So we can say some amount of water at this state will try to convert into steam. So we have calculated that was about 40 gram. So we can say this much 40 gram water will convert into steam at 100 degrees Celsius. Now we're left with 60 gram of ice plus 60 gram of steam minus 40. So in total, 80 gram water and 40 gram vapor. Is it clear? Atif, any doubt?
No, sir.
Or should I repeat? Riba, is it clear?
Yes, sir.
Okay. You all have written?
Yes, sir.
Okay. So this is all about calorimetry and exchange of heat to change state or change in temperature. Next is transfer of heat. So there will be three different types of heat transfer. First is called conduction. Second is called convection. And third is called radiation. So let's start with conduction. Suppose you have particle in a solid arranged like this at some initial state like this. So if you raise the temperature of this particular particle from this end to this end, let's say temperature of this end is T1 and this other end is T2. So due to this temperature difference, or you will say due to raise in temperature at this left end, thermal kinetic energy of these particles would increase. According to the formula, kinetic energy equals to 3 by 2 kBT where T is temperature and Kb is its Boltzmann constant. So you'll say on raising temperature, thermal kinetic energy of particle at this first end will increase. And since on increasing energy, they will tend to vibrate to more distance, to this part, to this part. During this process, they may get collide with its neighboring particle, and due to collision, or you will say due to elastic collision with neighboring particle, they will transfer some of its energy to its neighbor. So the amount of energy may get transferred from one particle to another, and this process will continue till energy or heat energy flow from one part to another part. Atif, is it clear?
So can you repeat?
Okay. Suppose if you raise the temperature of this particular end. So on raising temperature, thermal kinetic energy of particle of this end may get increased related to this formula. So on increasing kinetic energy, they will tend to vibrate up to more distance, and hence they will collide with its neighboring particle. And on collision, they will interact with its neighboring particle and would transfer some of its energy. This process of collision, due to increase in kinetic energy of neighboring particle, will continue till flow of energy from one end to the other end. Is it clear?
Yes, sir.
Yusuf, any doubt?
No, sir.
So we can say on raising temperature, thermal kinetic energy of particle increases. So they will vibrate to larger distance and get collided with neighboring particle. And hence transfer some of their energy. This process will continue till energy or heat get transferred from one end to the other. Atif, any doubt?
Yes,
You all have written?
Almost done, sir. Done, sir.
Okay. So to define this particular process, let me define you similarity between electricity and heat conduction. Suppose we have a conductor having area of cross section A and length L. Similarly, for heat conduction, I have taken another conductor having area of cross section A and length L. Riba, just tell me, what will be the basis of flow of electricity in a particular conductor? How there should be flow of electron in a particular conductor. So you'll say you must need some voltage difference between their end, which will be necessary for flow of current. So let's say this is V1 and V2, voltage difference, or you may say potential difference, equals to delta V, V1 minus V2. Similarly, in this part, for heat conduction, we must need potential or temperature difference at their end. So it will be T1 and T2. Atif, any doubt? Okay. Next, in this particular conductor, there will be some opposition caused in the flow of electron or charge through it, which is called a resistance. So we may define electrical resistance or simply resistance. R equals to rho L divided by A, You must have learned this particular formula in class 10th, where rho is called resistivity, L is length of conductor, and A is area of cross section. Now, we may write resistivity as a reciprocal of conductivity, or in terms of heat, it is called K. So this rho is called resistivity. So this sigma is called conductivity. So in terms of heat, K is called thermal conductivity. So we can write in terms of heat conduction, a resistance offered by this substance for the flow of heat through it. So R equals to L, rho is 1 by K times A. Riba, is it clear? Nida, any doubt?
No.
Okay. Now we have voltage difference and resistance offered by the substance. So we can define amount of current flow through this particular conductor. So according to the formula, current is simply flow of charge by time taken. So it will be charge divided by time. So it will be Q by T. Similarly, in heat conduction, we call it as heat current. So it will be defined by flow of heat per unit time. So heat flow divided by time taken. Heat is represented by Q and time taken is T. Heat current is represented by H. Atif, any doubt? Now just tell me, you must have learned about Ohm's law in class 10th. Do you have any idea? Atif, define Ohm's law.
The potential difference is proportional to current.
Good. So we can write V equals to I into R from that part. So voltage difference equals to current into resistance. So from this, we can write current equals to potential difference divided by resistance. Just put the value of each term in this expression. We have R equals to rho L by A. So on solving, you will get A times delta V divided by rho into L. You may write rho in terms of sigma, so it will become sigma A delta V divided by L as electrical current, or it will be equals to flow of charge divided by time taken. Reba, is it clear? Similarly, we can write for this heat current according to this Ohm's law. In this part, potential difference is related with temperature difference. Electrical current is related with heat current. So we may write delta T equals to heat current times thermal resistance. So heat current equals to temperature difference divided by thermal resistance. If you put the value of R as above what we have calculated, so it will become Ka delta T divided by L, or this will be equal to Q by T. So there is equivalent relation between electricity and heat conduction. Nida, is it clear? Yusuf?
Yes, sir.
Okay, just write it down till this part. So try to relate this particular formula, or try to remember this particular formula according to this relation. Riba, I'm unable to hear you.
Sir, can you scroll up once again?
Okay.
Thank you, sir.
You all have written?
Writing, sir.
Yusuf, done?
Yes, sir.
Related to the above part, let me give you a question. Suppose you have cuboidal slab. At this face, it is connected by furnace, 100 degrees Celsius. And at this end, it is joined to ice at 0 degrees Celsius. Length from this point to this point is 20 centimeter. From this point to this point is also 20 centimeter. And its length is 50 centimeter. Thermal conductivity is 0.8 watt per meter per Kelvin. So using this part, try to find first, find delta T. Second, temperature gradient. Third, heat current. Amount of heat transferred in 1 minute. Try to find using the above diagram. Okay, Atif, find the other part. Riba, what do you mean by temperature gradient? Nida, what do you mean by gradient? Just see. Gradient is change of any quantity with respect to change in length. So in this part, we have to calculate temperature gradient. It means change in temperature divided by length. Try to find. Go to yourself. Temperature gradient is change in temperature divided by length. So you have calculated temperature difference and we have total length from one end to other end is 50 centimeter. So convert it in terms of meter. So it will be 50 divided by 100 or 1 by 2. Next, for thermal resistance, R equals to length divided by K into A. We have length. We can calculate area of this particular face. And we have K. Then use Ohm's law. Current equals to temperature difference by resistance. Try to find these. Good yourself.
Sir, is the third one correct?
Just 1 minute, let me check. Temperature difference from one end to other ends 100 minus 0, so you'll get 100 degrees Celsius. Temperature difference 100 by length 1 by 2, so it will be 200 degrees Celsius per meter. Third part, we have length 50 centimeters. So in terms of meter, it will be 0.5, K 0.8, area of cross section 0.2 into 0.2. So if you multiply it, 5 divided by 8 into 2, 16 into 2, 32. So 0.5 divided by 1 decimal, 2 decimal, 3 decimal. So it will be 0.032. Move this decimal. So it will be 10 and 1000. So this 0 and this 0 will cancel out. So you'll get 5 divided by 32. Just 1 minute. So it will be around 1.5625. So you will say 1.6 into 10 to the power minus 3. Length per kA. Then put in this last part, delta T is 100 degrees Celsius and resistance is 1.6 into 10 to the power minus 3. Just simplify it, you'll get heat current. Yusuf, is it clear?
Yes, sir.
Riba, any doubt?
No, sir.
So in last part, if you have to calculate amount of heat transferred in 1 minute, so H equals to Q divided by T. So from this part, you can say Q equals to H into T. So just multiply it by 60 seconds. Atif, just check your calculation for fourth part.
Sir, how did you get the fourth answer?
We have temperature difference as 100 and thermal resistance, what we have calculated as 500 divided by 32. Okay, let me simplify it. H equals to temperature difference divided by thermal resistance. Temperature difference we have 100 and thermal resistance is 500 divided by 32. So it will move to numerator like this. So this 0 and this 0 will cancel out. Okay, I've done a little mistake. So 5 and 6.4 times. Why is it wrong? Oh, it will be plus 3 and plus 3. That's why it will be 6.4. Okay, Yusuf.
Yes, sir.
Atif, is it clear?
Yes.
Okay. Riba? Okay. You all have written?
Yes, sir.
So for this concept, we may use all the concept of electricity what written in class 10th, like series combination and parallel combination as well. So related to that part, you'll be asked, suppose you have a rod whose one end is at 100 degrees Celsius and the other end is at 10 degrees Celsius. Area of this particular end is twice A as compared to this part. Thermal conductivity is 0.8 watt per meter per Kelvin and thermal conductivity of this part is 0.5 watt per meter per Kelvin. So you will be asked to find temperature of this particular junction T0 if length of these two rods are equal. Find temperature of junction. So let me define you how to approach this part. First, you will say, since we have 100 degrees Celsius at this left end and T0 at this middle part, so there will be heat current flowing from this 100 degrees Celsius to this T0. Let's say this particular heat current is H1. Similarly, there will be another heat current in this second wire from this point to this point, let's say H2. So we can calculate H1 equals to Ka by length, temperature difference 100 minus T0. Similarly, for second rod, H will be equals to Ka by length, temperature difference T0 minus 10 degrees Celsius. Atif, just tell me about this particular combination. Is it series combination or parallel combination? These two rods?
Is it series?
Good. So in class 10th, we have defined or learned in series combination, current will be seen. So we can say H1 must equals to H2. Riba?
Yes.
So since rod is in series combination, so H1 must equals to H2. Now put all the values in this part. K is given, A is given, L is given, and try to find the value of T0. Yusuf, is it clear?
Yes, sir.
Okay, try to solve for T0. Yusuf, got your answer?
Doing, sir. Sir, what's the value of L?
In both sides, we have same L, so L will cancel out.
Okay, sir. Thank you.
So A and L will cancel out in both sides. Just simplify it. Atif, you got any answer? So if you multiply this part, you will get 1600 minus 16 T naught equals to 5 T naught minus 50. 16 T naught move to right side and 50 to left side. So it will be 1600 plus 50 equals to 5 T naught plus 16 T naught. So 16 plus 50, it will be 1650 equals to 21 T naught. So from this part, T naught will be 1650 divided by 21. So on solving, you'll get 78.6 degree Celsius. Atif, Reba,
Yes,
is
sir.
it clear?
Yes, sir.
You got this answer
Somewhat
or
close
something
to it,
else?
sir.
Okay. 1650 divided by 21. So it will be 78.57, or you'll say 78.6 degrees Celsius. Riba, any doubt? Nida? Okay, so let's stop here for today. In next class, I will define you combination of rod, like what we did in 10th class for series combination of resistance, R equivalent equals to R1 plus R2 plus R3, And similarly, in parallel combination, we calculated 1 by R equivalent equals to 1 by R1, 1 by R2, and so on. So we have to calculate similarly for this part for K equivalent. Okay.
Okay, sir.
Okay, then we'll continue in next class. Take
Thank
care.
you,
Good
sir.
night.
Thank you, sir.